The last shape to tackle here is, I think, the hardest one to produce. And if someone has a different idea, I would love to hear it. I thought I had it, but Simon Gregg was quick to point out that my measurements were wrong. Here's what he's referring to. This is what I thought I originally came up with, but I'm just dumb. If I had paid attention to simple right triangle trig, I would know that this is 1 inch and this is not, because the height would be less than the hypotenuse of this right triangle. So that's out. All right. So here's what I've come up with. And again, if you have a suggestion, send it my way. I'm sure I'll hear from Paula or Simon or Karen or somebody else with a different idea. But here's what I came up with. Again, as before, I'm going to mark the centroid of my equilateral triangle. And I'm going to start by bringing the top vertex down to meet the centroid. Okay. I find by doing that, it establishes that 1 inch side length. You know, you got the equilateral triangle, all of the sides of every shape, except for, again, the trapezoid, are 1 inch in length. So the edges of this tan rhombus are all 1 inch. Okay. Now I know I need a 30-degree angle, which I have here, right? That's a 30-degree angle when I take this midline here. So I've got that angle sort of established. And I know that this side here, let me grab a highlighter. If I highlight this edge of that equilateral triangle, I know that that's 1 inch, right? So I need to now duplicate that side length for the other three sides of that tan rhombus. So here's what I came up with. I'm actually going to cut my equilateral triangle in half. You don't have to, but this will just make it a little easier for me to manipulate. Right, so you could actually save that, and then you can make more of the tan rhombuses from that scrap there. Okay, so what I need to do is I'm going to actually fold an angle bisector of this 30-degree angle, which is a pretty neat little thing to show kids, is how to fold an angle bisector. So I'm going to bring this left edge from the equilateral triangle onto this altitude of the equilateral triangle. So I'm just going to turn it this way and see if I can get this folded nicely. Ooh, that came out pretty good. All right. Okay. So let me just sort of dot that in. All right. So that's the angle bisector of that 30-degree angle. Okay. Now what I need to do is I want to bring this vertex, this 30-degree vertex, over and onto that dotted line. So it's almost like I'm doing a reflection, but I want to make sure that I keep this 1 inch side length. All right. And again, if anybody has a suggestion on a different way to do this, please send it my way. So if I fold it down, and then I'm just going to sort of rotate it onto that angle bisector. Okay, so this point right here should be where that 1 inch side stopped. Again, so I just folded it down like I folded the equilateral triangle down, but now just sort of pivot it over onto that angle bisector line. Just trying to get over just a little bit. And there we go. Okay, and then crease it. All right. So I'm just going to leave that there, and now take my scissors and cut. It's kind of hard to see on the camera here. I'm going to try and cut right along the edge of that flap there carefully. All right. Let's open this up. So that should be the tan rhombus with 1 inch sides and those angles of 30 and 150. All right. I think that works. And again, if you have any suggestions on a better way to come up with that little tan rhombus, please, please, please send them my way. All right. So we've got one more video where we sort of put it all together and some final thoughts, and we'll see you then. Thanks.